Okay, we're going to talk about parallel lines today, and we're going to use our first postulate is going to be the same side interior angles postulate. We'll talk about that in a second. Let's just do some review from last year. So once again, we're talking about parallel lines. The idea is we're going to be proving some theorems that you know. For example, the alternate interior angles are congruent. Corresponding angles in parallel lines are congruent. You've worked on that, but you were just told that, and we're going to actually prove it today. Everything in math you should be able to say, why is that true? Okay, so the first thing we're going to talk about is the idea of a transversal. Now, I'm going to draw two lines here. Here's L and M. L and M meet here at this point, but I could also make the lines parallel. It doesn't matter because I can still draw a transversal through them. A transversal is a line that passes through two other lines at distinct places. So if there is an intersection point, it's not passing through that. So I can draw a transversal here, and I can draw a transversal here. So a transversal is a line that intersects two lines at distinct points. When I say distinct points, I mean it does not pass through a potential intersection point. Once again, we're going to get to what you remember. So what we've done is we've created, so we have something called an interior region and an exterior region. So the region between the two lines is known as the interior. Here's the interior, here's the interior. The region outside the lines is known as the exterior region. Here's the exterior. And here's the exterior for the second diagram. Okay. Now, like last year, what you'll remember is that drawing a transversal through two lines creates these 8 angles. And so I'm going to label both of them the same way. 1, 2, 3, 4, 5, 6, 7, 8. And then for the parallel lines diagram that you're more familiar with, we're still going to use the same label. 1, 2, 3, 4, 5, 6, 7, 8. Okay. The next thing I want to do is I want to talk about the pairs. The first pair of angles that you're familiar with is corresponding angles. The corresponding angle. So the idea that corresponding is a fancy word for match. Like take your hands and go like that. You know, the thumb corresponds with the thumb, and the pinky corresponds with the pinky. So the idea is that you're going to take 1, 2, 3, 4, and literally like plop it on top of 5, 6, 7, 8. So we can see that angle 1 corresponds to angle 5. Angle 2 corresponds with angle 6. Angle 3 corresponds with angle 7. And angle 4 corresponds with angle 8. We're going to determine later if they're actually congruent, but the idea is they are corresponding angles. We'll see that if corresponding are congruent, then our lines are parallel. If they're not congruent, they're not parallel. We'll get there. Next, the next thing we want to look at is alternate interior. Alternate interior. So let's start with what you know, you might be familiar with. We're looking in the interior, the purple region, and what angles are on the opposite sides of the transversal? Alternate. So angle 3 and 5 are alternate interior angles. And we can see that angle 4 and angle 6 are alternate interior angles. Once again, their relationship will tell us whether the lines are parallel or not. We'll get to that. The next thing we want to talk about is alternate exterior. Alternate exterior. Same idea. we look in there's 4 angles in the exterior, 1, 2, 8, 7, and which ones are on the opposite sides? Well, 1 and 7 are alternate interiors. Angle 1 and angle 7 are alternate interiors, and angle 2 and angle 8 are alternate interiors. It's the same thing for the diagram of the lines that clearly intersect. 1 and 7 are exteriors on alternate sides, and 2 and 8 are exteriors on alternate sides. And once again, this relationship will tell us, the relationship will tell us whether the lines are parallel or not. The last thing we want to talk about, and this is going to be our segue into the proofs, is same side interior. Same side interior. And it's clear from the words, we know we're going to 4 and 5, they're both interiors and they're on the same side. So angle 4 and angle 5 are same side interiors. And let's just, obviously 3 and 6 are also. Let's jump into our same side interior angle postulate. It's a postulate. We're accepting this to be true. This is what we're going to build off of. And the postulate is, if 2 lines are parallel, then the same side interior angles are supplementary. That's our postulate. And now from that, we can build off everything that you say, hey, Mr. Hartley, we know, it's congruent. We know that. My answer is why, and beyond your teacher told you, let's do a proof. So let's start with the first theorem. Theorem 1. Well, not theorem 1, we have a couple of theorems. Theorem, if two lines are parallel, then the corresponding angles are congruent. Then the corresponding, sorry, I'm really sloppy. The corresponding angles are congruent. How are we going to prove that? Well, how are we going to prove that? Well, we're going to make a 2-column proof. Statements and reasons. Everything in the hypothesis is given. If I start you off with a hypothesis, you go, okay, Mr. Elder told us that. So what is in the hypothesis? First of all, if 2 lines are congruent. So, let's see. L is parallel to M. Given. What else do we know? Well, what are we trying to prove? On the top, I usually write on the top, I'm like, prove what? So let's take a look at this. Well, I'm trying to prove my corresponding angles are congruent. So how can I prove that angle 1 is congruent to angle 5? That's what I have to prove. Prove angle 1 is congruent to angle 5. Well, where do I start? Well, you know what? What do I know if 2 lines are parallel? Well, from my postulate, I know the same side interior angles are supplementary. So I know that angle 5 plus angle 4 equals 180 degrees. Why? Same side interior angles postulate. Why is that true? Because we're accepting it as true. Next. What do you think? What do you think? Well, what's another relationship? Oh, you know what? Angle 1 plus angle 4 equals 180 degrees. Why? Definition of linear pair. And we're done. Well, we're almost done. Well, what's next? Well, we can speed the process up. Can you see the board? Yeah. What's next? Well, I know that angle 1 plus angle 5, I know that angle 1 plus angle 4 is equal to angle 5 plus angle 4. Why? Transitive. What's the last thing? Angle 1 is congruent to angle 5. Subtraction postulate of equality. What did we just prove? We just proved that if two lines are parallel, corresponding angles are congruent. Next, what's the next thing we need to prove? What is the next thing we want to prove? Alternate interior angles. You're like, Mr. Adler, if two lines are parallel, alternate interior angles are congruent. That's our next theorem. Now, once you prove that, once we prove, therefore, if two lines are parallel, then corresponding angles are congruent. You don't have to prove this again. Like, that's the point. We've proven it, and now we can use it. So when someone says to you, how do you know that's true? You say, that is our truth in math. Let's try the next one. Prove theorem. If two lines are parallel, then the alternate interior angles are congruent. As I said before, you did this last year. Like, you know. You're like, Mr. Adler, 3 is congruent to 5. So, you know, we need to prove angle 3 is congruent to angle 5, or angle 4 is congruent to angle 6. You can do either one, or you can do, because if you do one, the other one falls into place. Next, so what do you think? Well, what's in the hypothesis? Whatever, in this class, I'm giving you true statements. So whatever's in the hypothesis is going to be true. So you know what? Statement, reason. 1, L is parallel to M. I'm calling it L and M. You can call it K and J, A and B, Q and Z. I don't know, but I'm calling it L and M. I have my 2 lines. I'm telling you, there's 2 lines, they're parallel. Given. Any suggestions? Any suggestions? How about we say that angle 1 is congruent to angle 5 because the theorem, corresponding angles are congruent. We just proved that. The second you prove something, you get to use it. Okay, what else? How am I going to get 3 and 5 connected? How am I going to get 3 and 5 connected? Well, is there a relationship that we've proved that connects 1 and 3? Yeah, angle 1 is congruent to angle 3. Why? Vertical angles. In the last class, we proved if 2 angles are vertical, they're congruent. Therefore, we get to use it. Next, are we done? Yeah. Angle 3 is congruent to angle 5. Why? Transitive property or substitution. I think the book uses transitive. It's not really a big deal. Like, I'm going to let it go. Let's just call it transitive. Let's call it transitive. Should we move on? So are we done? Yeah, we've proven it. QED. Therefore, we're done. I don't need to write it over again. We're done. Nice. We've proved that 3 is 5. Can you prove that 4 is congruent to 6? Can you prove that 4 is congruent to 6 while we're here? Yeah, because why is 4 congruent to 6? In the last class, we proved that supplements to congruent angles, In the last class, we proved that supplements to congruent angles are congruent, right? Because 4 is supplementary to 3. Actually, 4 is supplementary to 5, and 6 is supplementary to 5. Therefore, 4 is congruent to 6. And so we've just proved alternate interior angles are congruent. Or angle 4 is congruent to angle 6. You want to do the exteriors? What about the exteriors? Theorem. If 2 lines are parallel, then the exterior angles are congruent. Well, can I just continue with this proof? Yeah, let's just continue. Let's continue the previous proof. Let's continue the previous proof. So let's look at 4 and 6. What are we trying to prove? We're trying to prove that angle 1 is congruent to angle 7, and 2 is congruent to 8. Let's look at angle 1 is congruent to angle 7. As I said before, you did this last year because your teacher told you it's true. Now this is how we actually prove it. We know that 4 is congruent to 6, right? Well, angle 4 is congruent to angle 2, right? And angle 6 is congruent to angle 8, right? Because they're vertical angles. Well, what's the next step? Well, then we can say that angle 2 is congruent to angle A, because I guess substitution. I'm not asking for this on the proof, and anything is fine. I just wanted the idea. Oh, sorry, guys. Continue the previous proof. We proved that angle 1 is congruent to angle 7. Then we have to prove that. We said that angle 4 is congruent to angle 2, and angle 6 is congruent to angle 8. Therefore, whether it's substitution or chain rule or flipping around, we're just going to say substitution. 2 is congruent to 8. Therefore, alternate exterior angles are congruent. I want you to work on that. And then I'm going to tell you something. So the idea is, so we've proven this now. So now the exercises for the unit are just applications. The next unit, 3-4, actually says the converse. And the converse, it starts with the converse. It says the converse of the same side interior angle postulate is also a postulate, which is saying if you have 2 lines cut by a transversal and the same side interior angles are supplementary, then the lines are parallel. From that, we can prove the converse of these 3 things. We can say if the alternate interior angles are congruent, then the lines are parallel. Sorry. We can take, and from that, we can prove that if the corresponding angles are congruent, then the lines are parallel. And then from that, we can say if the alternate exterior angles are congruent, then the lines are parallel. So we go both ways. As I said before, your teacher back then said, these lines are parallel, find the angles. In this class, we're flipping it, saying, find the relationship between these angles and show the relationship between the two lines. Good luck.